lecture, we will discuss about one example of two-span continuous beam in which there is two different plastic moment of resistance. Okay, and after that we will discuss about our portal frame. Okay, so in portal frame there is three mechanisms. First one is beam mechanism, second one is sway mechanism, and at last it is combined mechanism. Okay, after that we will discuss about the portal frame based on their support systems. And in portal frame there are three types of support systems at in which in first type your both the supports are fixed support. In your second type your one support is your simple support and another support is your fixed support. And in the third type your both the supports are simple support. Okay, after that we will discuss about our example number 1 in which there is one vertical load is acting and other load is horizontal load, and this horizontal load is acting exactly at the junction point. Okay, and this horizontal load is considered for sway mechanism. Okay, so in this example we will discuss about our three mechanism. First one is beam mechanism, second one is sway mechanism, and at last it is combined mechanism. Okay, so now we are moving further to our example number 2. So in example number 2 the question is determine the plastic moment for the portal frame as shown in figure. Okay, so you can see that this is your portal frame in which your both the supports are fixed support. Now all the members have the same plastic moment of resistance. It means your all the three spans, span AB, span BC and span CD having same moment of resistance, so it is MP. Now the point load is acting on the horizontal support, horizontal span. It is 20 kilonewton and it is acting at 1 meter from left support. Okay, this point load is not acting exactly at the center point. Now you can see that it is clearly mentioned that take load factor is equal to 1.7. It means in this example the given load is your working load. Okay, now and in this figure it is clearly mentioned that one horizontal load having the value of 6 kilonewton is acting at the junction point. So this example is somehow the revision of your example number 1. Okay, so now you can see that this is your fixed support, so it takes moment. This is your intermediate support, so it is also takes moment. This is the point of load, so this point is also takes moment. This is your C, so this support is your intermediate support, so this support is also takes moment. And your D is your fixed support, so this point is also takes moment. So that's why in this system there is 5 points which takes moment, so it is A, B, C, D and E. Now we are moving further to our first mechanism, which is beam mechanism. So in beam mechanism you can see that there is one load which is acting at 1 meter from B support. Okay, and the value of this load is 20 kilonewton, but this load is your working load. So now we are moving further to convert it to factor load. So your factor load is 34 kilonewton. Now you can see that the left distance is 1 meter and right distance is 3 meter. It means this load is not acting exactly at the center. Okay, so now if the distance is different, then the angle is also different. So you can see that this is theta and this is theta 1. Okay, so at this point it is okay. Okay, so this is 34. There is some typing mistake. So 34 into 1 theta. So it is 34 into 1 theta. Now if your distance is different, so there is one relation which is 1 theta is equal to 3 theta 1. So you can see that the relation is theta is equal to 3 theta 1. It means your value of theta 1 is theta by 3. Now your internal work done. So your internal work done is mp theta. At this point it is mp theta plus theta 1, and at this point it is mp theta 1. Okay. Now we are putting your value of theta 1 is equal to theta by 3, and you will get your answer 8 by 3 mp into theta. There will be some typing error in which mp theta plus theta 1 and mp theta 1 is not typed over here. Okay. Now you can see that your both the answers in the form of theta, so you can equalize this value. So it is 34 theta is equal to 8 by 3 mp theta. So you can see that this point is typed over here. Okay. Now your value of mp is 12.75 kilonewton into meter. So this is your first mechanism. Now your second mechanism is sway mechanism, and you all know that whenever your horizontal force is acting at the junctions, then your frame is sway like this. Okay. So your horizontal load is 10.2 kilonewton, and it is deflected as the this point. Okay. So you can see that this is your angle is theta. So this deflection is 4 theta because it is 4 into theta. Now external work done is equal to 10.2 into 4 theta. So it is 40.8 theta. Now it is the revision of your last example in which these A, B, C and D all the points takes moment. So it is 4 mp theta, and after that we are equalizing both the values, and it is 10.2 kilonewton into meter. Okay. Now your third mechanism is combined mechanism, and in combined mechanism we have to consider both the horizontal and vertical loads. So you can see that this figure is given in the question. So it is unfactored load. So we have to convert unfactored load to factored load by multiplying the value of 1.7. Okay. Now this is your 34 kilonewton and the distance is different. This is 10.2. So this is your deflection. It is 4 theta and this is 1 theta. Okay. So now your total external work done is 10.2 theta into 4 plus 34 into theta. So it is 74 theta. Now your internal work done is mp theta at this point, mp theta at this point, mp theta plus theta 1 at this point, mp theta 1 at this point, and at last it is mp theta. Okay. So now we are putting the value of theta 1 is equal to theta by 3, and we will get our answer 14 by 3 mp theta. Now you can see that your both the answers is in the form of theta, then you have to equalize this value, and your answer is 16.0285 kilonewton into meter. Okay. Now you all know that whenever in the question it is asked that find out plastic moment, then you have to consider largest value. Okay. So largest value of the plastic moment is considered as your design plastic moment. So it is 16.0285 kilonewton into meter. Okay. So students, this is the end of your example number 2. Now some change is in example number 3. So this change is UDL. Okay. And you can see that your portal frames both the supports are hinge support. So The question is a portal frame is loaded up to collapse as shown in figure. Find the plastic moment of resistance if it is of uniform strength. It means MP is given in all the frames. Okay. Now you can see that this point is not take any moment. This is your intermediate support. So at this point moment is taken by the junction. This is your C and this is your intermediate support. So it takes moment. This is your D point. So it is hinge support. So hinge support doesn't take any moment. And at the center span, it is takes moment. So in this system, there is 3 points B, C and E, okay, which takes moment. So your number of plastic moments is equal to 3. Now our first mechanism is beam mechanism, and you all know that this is your fixed support because it is intermediate support, and this is also your fixed support. Now if your both the supports are fixed and UDL is acting throughout the span, then you have to convert your UDL to point load by multiplying it with some length. Okay, and this length is your span of that beam. So this is your 10 kilonewton by meter, and this span is 8 meter. So 10 into 8, which is equal to 80 kilonewton. Okay, now if your whole dimension is 8 meter, then it is 4 and 4. Okay, now you all know that if the load is acting exactly at the center point, then your both the deflection angle is remain same. So it is theta. At this point it is theta, and at the center it is 2 theta. Now what is this deflection? This deflection is generally 4 theta. But you all know that whenever UDL is given in the question, then you have to consider as your average deflection. So 4 theta by 2, which is equal to 2. Now your external work done is equal to 80 into 2 theta, and your internal work done is MP into theta, MP into 2 theta, and MP into theta. So it is 4 MP theta. Now equalizing both the values, and you will get your answer 40 kilonewton into meter. Okay. Now this sway mechanism is very simple because there is only 2 points which takes moment, and it is B and C. Now 25 kilonewton load is acting on horizontal side. So your frame is deflect like this, and this deflection is 4 theta because 4 is your length and theta is your deflection value. Okay, now your external work done is 25 into 4 theta, which is equal to 100 theta, and your internal work done is 0 at A junction, MP theta at B junction, MP theta at C junction, and 0 at D junction. It means it is total 2 MP theta. Now your external work done is equal to internal work done. So your MP is equal to 50 kilonewton into meter. Now the very most important term is combined mechanism. Okay. So you all know that whenever UDL is there, but at the same time, if vertical load, UDL and horizontal load is acting simultaneously, then your frame is deflecting like this shown figure, then it is not compulsory that your this point load is now acting exactly at the center. So at this case, prop cantilever case is now possible. Okay, so you are thinking about that your both the supports are fixed support, so why it is prop cantilever beam? But it is just because of your horizontal force is acting simultaneously. Okay, so this is your horizontal force having the value of 25 kilonewton, and this is your value of point load which is converted by the UDL, and this distance is x, so this is 8 minus x. Okay, so you all know that your external work done is 25 into 4 theta plus it is 80 plus x theta, but you have to consider your average deflection, so it is x by 2 into theta. Okay, so your external work done is 100 theta plus 80 into 1 by 2 into x theta. Now your internal work done, so at this point it is mp theta, at this point it is mp theta plus theta 1, and at this point it is mp theta 1. Now, what is the relation between theta and theta 1? So you all know that x into theta is equal to 8 minus x into theta 1. So your theta 1 is equal to x into theta divided by 8 minus x. Okay. So after putting the value of theta 1, which is equal to x theta divided by 8 minus x. So if you are solve this example, so your answer of internal work done is 2 mp theta in the bracket 8 divided by 8 minus x. Now we have to multiply this two value with this 8, so it is mp theta is equal mp theta into 16 by 8 minus x. Now we have to find out mp, so now you can see that mp is equal to 8 minus x is multiply with this value and 16 is going to the denominator. This theta is typing wrongly. Okay, so now your mp is equal to 8 minus x into 100 plus 40 into x in the bracket 8 minus x divided by 16. So now this case is solved just like we have to solve the example based on the cantilever case, which is case number 8. So you can see that this 16, now 8 into 100, so it is 800 minus 100x plus 320x minus 40x square divided by 16. So your final MP is 800 plus 220x minus 40x square divided by 16. Now, first of all, we have to find out x, at which point your moment is to be maximum. So, whenever you have to find out the value of x, then you have to derive that x equation, okay, with derivation. So, it is dmp by dx is equal to 0. Now, 800 is constant, so the derivation of 800 is 0. The derivation of 220x, so it is 220 minus the derivation of 40x square, so it is 80x. Okay, so your final answer of x is equal to 2.75. This is the distance from B point. Okay, now if we are putting this value of x in this equation, then we will get our answer of mp is equal to 68.9 kilonewton into meter. And you all know that the largest value of mp is considered as your design plastic moment, so it is 68.90 kilonewton into meter. Okay, so students, this is the end of today's session. Thank you.